Hey, welcome back. Today we are pulling back the curtain on software design to see what happens when things, well, go wrong. We're going to explore one of the clever systems built to handle failure, specifically how a really well-designed application tells you when something you tried to do just didn't work. You totally know this feeling, right? You're trying to create an event or maybe submit a form. You click the button, maybe you see that little spinner for a second, and then just silence. Did it work? Did it fail? Who knows? You're just left hanging, and honestly, it's one of the most frustrating things you can experience with any piece of software.
Yeah, that whole experience, it's got a name. It's called a silent failure. It is a classic headache for both users and the developers who build these things, and it is the exact problem we're going to see solved today. From your point of view, it really does feel like your request just vanished into thin air. There's no feedback, so you're left wondering, okay, should I try again, but what if that creates a duplicate? Or you just give up. That complete lack of communication is a hallmark of a really poor user experience.
So how do we fix this? Well, the solution is the hero of our story today, a specific function from the Calendar Invite Server's technical docs. Its job is super simple, but incredibly powerful. When an event creation fails, it makes absolutely sure the organizer knows about it. No more silence, just clear, actionable information. To really get how this works, let's imagine the system isn't a bunch of code, but a highly efficient digital mailroom. It's designed specifically to handle bad news and make sure it gets to exactly the right person.
Okay, so this mailroom uses a toolkit of powerful Amazon Web Services, but each one plays a pretty simple role. Think of Amazon SQS as the main inbox where all the failure reports land. AWS Lambda? That's our tireless clerk who opens up every single report. AWS Code Commit is the filing cabinet where the clerk finds the right form letter. And finally, Amazon SES, that's the postal service that actually sends the notification email out the door.
So let's actually follow a single failure report on its journey, from the moment it's created to the second that notification email lands in the organizer's inbox. This is where the magic really happens. It all kicks off when a failure message lands in the SQS inbox. This immediately triggers our Lambda clerk, who springs into action. The clerk pulls out the key details, goes over to the code commit filing cabinet to grab the right email template, and fills it all out. Then it hands that finished letter over to the SES postal service for delivery. And here's the last and maybe most crucial step. Once the job is done, the clerk deletes the original message from the inbox. This is super important because it prevents the system from accidentally sending the same failure notice over and over again. Okay, but that brings up a really good question. What happens if the system that's designed to report failures has a failure of its own? I mean, a truly robust system has to plan for its own problems, and this one is no different. So the system has two main strategies for this. If our clerk, Lambda, goes to the filing cabinet and discovers the email template is missing, it doesn't panic. It just leaves the failure report in the inbox. The system assumes, hey, someone will probably fix this soon, and it'll just try again later. But what if the template is there, but the postal service itself fails to send the email? In that case, the system logs the error for a developer to look at, but then it deletes the message. It decides it's more important to move on to the next task than to get stuck on a single sending error. Pretty smart, right?
All right, now let's peek at the instruction manual for this function. Now, these aren't complex lines of code, but really simple settings. They're called environmental variables that tell our digital mailroom clerk exactly what to do.
These variables are really the secret to the whole system's flexibility. Instead of having details buried in the code, they act like simple settings for the inbox location, the template file, even the email subject line. What this means is that developers can completely reconfigure the notifications without ever having to touch the core code.
Okay, so we've seen all the nuts and bolts of how it works, but let's zoom out for a second. Why is a seemingly small background function like this so important in the grand scheme of things?
The ultimate goal here isn't just about sending an email. It's about creating transparency. The system turns a moment of absolute confusion into a clear, actionable notification. It gives the user power by telling them exactly what went wrong.
You know what's most fascinating is that the technical document is really clear about this. The main application could run perfectly fine without this function. It's not a critical component. But its value isn't in keeping the servers online. Its value is in building trust with you, the user. It's one of those small, thoughtful features that transforms an experience from confusing and frustrating to reliable and trustworthy.
So the next time you use an application that feels smooth, reliable, and just works, take a moment to think about the invisible systems, just like this one, working behind the scenes. What are the unseen, thoughtful functions that are handling errors gracefully, communicating clearly, and just generally making your experience better? Because it's those details that really separate good software from truly great software.